In this video, we're going to talk about ratios. And in problem number 7a, three friends shooting baskets in the schoolyard kept track of their performance. Andy made 9 out of 15 shots, Pat made 28 out of 40 shots, and Val made 15 out of 24 shots. Rank their relative performance. And so we want to compare how each of them did. And so one thing that we could do is write a ratio for each of them. So Andy made 9, that's the part, out of a total of 15 shots. And then Pat made 28 out of a total of 40. And Val made 15 out of a total of 24. So right now, just looking at these ratios set up as fractions, it's really hard to tell whether Andy did better or Pat did better or Val did better. And so we need to change this so that we can see which one really did better. And so the easiest way to do that is just to do the division that's represented by that fraction. And so just take oops, that's not what I wanted. I wanted my calculator. Take 9 and divide it by 15. So just take out your calculator and do that calculation. 9 divided by 15, and we get 0.6. And then 28 divided by 40, and that gives us 0.7. And then the last one, take 15 and divide it by 24. And we get 0.625. So now when we looked at the decimal representation, now it's easy to tell who did best, and that was Pat. He has the highest decimal number as his ratio of shots made out of total shots, and so he did the best. So which ratio form, fraction, decimal, or other, did we use to determine the ranking? And so we used the decimal. How would you determine whether two ratios such as 12 out of 20 or 21 out of 35 were equivalent? So there are various ways to do this. The first one is just to do the division like we did in the first problem. And the other one was 21 out of 35. The other way you could do this is cross multiply, and 12 times 35 what does that give us? Oops, let me clear that off. Gives us 420, and 21 times 20 gives us 420 also. And so these are actually equivalent ratios. So when you do cross multiplication like that, if you get the same number, then that means that the ratios are the same. The other way that we could do it is to do that division. And so if you take 12 divided by 20, we get 0.6. And if you do 21 divided by 35, you should get 0.6 as well. And another way that you could do it is by reducing the fractions, and they should give you the same ratio when you simplify the fractions. So the number that divides both 12 and 20 is 4, and 12 divided by 4 is 3, and 20 divided by 4 is 5, so we get 3/5. The number that divides both 21 and 35 is 7, and 21 divided by 7 is 3, and 35 divided by 7 is 5. And so when we reduce the fractions, we get the same fraction. So those are all different ways for you to compare numbers. I think the easiest one is probably to compute the decimal representation. And now we want to match each ratio from column A with its equivalent ratio in column B. And so first we have 15 out of 25, and so the easiest way I think to do this would just be to write these in decimal form. And so 15 divided by 25 gives us 0.6. And then 42 divided by 60 is 0.7. And 63 divided by 75 gives us 0.84. And 52 divided by 80 gives us 0.65. So now hopefully you can see the relationship, and so 0.6 is the same as 60 out of 100, and 0.7 is the same as 70 out of 100, and 0.84 is the same as 84 out of 100, and 0.65 is the same as 65 out of 100. Which ratio in each matched pair is more useful in comparing and ranking the four pairs? So if you had a choice to look at this type of ratio or this type of ratio, which one would you want if you were to compare things? And the easiest one to compare things with would be column B. And why is that true? Well, it's because they're each out of the same number here, and these are out of different numbers, and so it's hard to tell which one of these is better and which one is not. But because these are all out of 100, then that makes it more useful. And this is a good lead-in for the talk about percents, and we will pick that up in the next video. Let me know if you have any questions.